At its most basic level, chemistry is a study of matter and change. What is the universe made up of? What are the individual parts and pieces? And then what happens when you put those things together? And so what we're going to do to start off our more formal investigation of chemistry is we're going to look at a system of classification of matter. So take a look at this list of objects. Think about how you might organize it into categories, how you might classify them. Take a second and jot down, say, 3 categories that at least 2 objects off this list would fit under. And then write down those objects under that title. So go ahead and pause the video and take a second to think about that. Categories and objects that would go into those categories. So maybe your eyes got drawn here and you thought that some good category, or a good category, would be metals. So we have copper, we have platinum, we have 14 karat gold, and 2 of these have a further category that separates them from the third, primarily being that 14 karat gold is an alloy, it's a mixture of metals, while copper and platinum are pure elemental metals. They can be found on the periodic table. Perhaps you looked here and thought to yourself, a list of gases. Well, that could be a good category, but you need further information in order to be able to use gases as a category here, because not all of these substances are gases under all temperatures and pressures. And at certain temperatures and pressures, some will be liquids and some will be gases. We could potentially have some being solids while others are liquids or gases. So you need to specify conditions. And if you have to specify conditions, then possibly a better category could be generated. Perhaps we take a look at this one and you might say liquids as a list, but since we already kind of discussed state of matter not being a really good measurement, and even if you go to the grocery store, you can buy liquid bottled water, powdered Kool-Aid, and frozen orange juice. So liquids might not be a good thing here, but things that you drink might be a good classification for that, as we generally don't drink chocolate chip cookies. And so states of matter are an important concept, solids, liquid, and gases, but they're more about conditions of a particular type of matter rather than a classification that can help us differentiate matter. And we will certainly come back to the idea of states of matter several times throughout this class. But as a more generalized discussion of matter, the universe can more or less be split into 2 kinds of things. And typically in science, we measure these things differently, and that's matter and energy. Matter is anything that you can hold in your hand. It takes up space. It has mass. You can, say, go to the ocean or the beach and pick up a handful of sand and take it to your mom and say, hey, look, Mom, sand. It's a little bit more difficult to wade waist deep in the ocean, scoop your arms together and come back on the beach and say, look, Mom, a wave. Energy doesn't transport like that. Energy spreads out in space. Energy can overlap with other energy, whereas matter cannot overlap with other matter. And so matter and energy are fundamentally different in the measuring within science. But of course, in the early 20th century, this guy, who's pretty famous, I imagine you all know the name that goes along with this face. Sometimes he's got a little bit crazier head of hair. But in the early 20th century, Albert Einstein gave us this famous equation, E equals mc squared. And essentially what's going on in this equation is that the E stands for energy. And that is equal to the mass of a certain amount of matter times c squared, which we've looked at c as a variable in some of our previous videos. That's the speed of light. But that equals sign in the middle there tells us that matter and energy are not fundamentally different. They actually are 2 different manifestations of the stuff in the universe. That said, the individual manifestations of matter and energy are measured differently in the universe. We're going to focus now on the matter side of this equation. A good definition for matter is anything that has mass and takes up space. So there are 2 conditions we're looking at here, and they are certainly related. Mass is a measure of the quantity of matter in an object. It's how much stuff you have. It's an accounting of particles at the atomic and subatomic level, if you will. It's how many constituent pieces make up a sample of matter. To take up space is to have volume. And so if you have mass and you have volume, then it's probably a good bet that you're measuring a particle or a sample of matter. There are two general properties we use to describe matter. One of them is called an extensive property. An extensive property depends on the amount of matter in the sample. It's sample dependent. It's how much you have. An extensive property cannot identify a sample of matter for you. So mass, for instance, is an extensive property. I can weigh out 10 grams of candy corns, and I can weigh out 10 grams of chocolate-covered raisins. There are some of you that would be more thrilled about one 10 gram versus the other 10 grams. But that 10 grams itself cannot tell me what kind of candy I have there. And then we have what's called an intensive property. An intensive property is in the sample of matter. It does not depend on the amount. It is substance dependent. Melting point is a good example of an intensive property. Water melts at 0 degrees Celsius at sea level, regardless of whether I have a swimming pool full of water or if I have a teaspoon of water. So intensive properties help you identify a sample of matter. An interesting way to look at this intensive-extensive situation is to look at density. And those of you that remember your density equation, density is equal to mass over volume. Mass, as we've already said, is an extensive property. It does not depend on what you have, only how much you have. You put whatever substance you have on the scale until it reaches a certain mass, and that's how much you have. Volume, which is the amount of space something takes up, is also extensive. If I have more stuff, it's going to take up more space. But this ratio of mass to volume is the same no matter how much stuff you have. And a density can actually be used as an intensive property. It's a way to identify a sample of matter. Water's density at the same temperature is the same regardless of how much water you have. Famously, of course, this intensive property was used by Archimedes to determine whether or not the king's crown was actually made of pure gold or an alloy, because he was able to measure the density of this irregular object and tell us whether or not that density matched the density of pure gold.